Hello, welcome to Eason Academy. And now in this session, we are going to look into the number systems part 4. And it's a small continuation of what we have seen the last session, where we discussed about binary operation. Okay, so today we are going to continue that, and we will try to complete the basics binary operation. That's basically addition, how we handle it on the binary number system. That will be very, very useful when you're getting into the digital electronics. So, how exactly the digital electronics is performing addition? That and this, if you add it, it will be very, very useful for us. Now, let us get into the board. Okay, so the last session, we added 1, 0, 1, 1, 1, 1, 1, 0. Simple. 1, 0 is 1, 0, 1 is 1, 1, 1 is 2, 0, and carry is 1, 1, 1, 1 is 1, and 1, 3. And you know that we have discussed that starting the carry is always 0. So here also no carry, so carry is 0. 0, 1, 1, the carry is 0. So actually we are adding 3 numbers. We don't add 2 numbers, we are adding 3 numbers. It looks to be 2 numbers, but we actually add 3 numbers because of the carry. Just think of a minute. In, a, in your school, in your primary school, they first teach you 7 plus 2, 9. So there will not be any carry. So we have done perfect. After a few days, after you have practiced this, they will teach you simple 9 plus 8. We'll have 17. That is fine. So we do this exercise for some time. Then they will teach you 12 plus 25. You'll say 2 plus 5, 7, 2 plus 1, 3. That is fine. But after completing this exercise, the class teacher will give 76 plus 48. Most of the kids, they write 8 plus 6 plus 8, 14, 7 plus 4, 11. So this will be the answer initially. But then the teacher will teach you, if you add the 2 numbers, it should be only 1 number, not 2 numbers. So the second number have to go as a carry. But if there is no other number, then you can write the carry. So what will happen? Your answer becomes 6 plus 8, 14, 1 in 12. Just recollect what exactly they do it in the school. After they teach this, they will teach you 1, 2, 6, 7, 9, 3. They will ask you to add 3 digit. You will perform 6 plus 9, 9 plus 2, 1, 1. Then you say 9. Teacher will say, very good. Now, it's a trick. After adding this number, then they will give you 4-digit number, 7593 plus 6839. You'll be adding very happily. Now you are thinking that, oh, I'm adding 1 digit, 2 digit, 3 digit, and 4 digit. You will go and tell your mom, mom, today the teacher gave me a 4-digit addition. I did it perform. And teacher also said, very good. I did all the things right. But if you notice one important thing, they don't teach beyond 4 or 5 digit. No school teaches you how to add 11-digit number. I never seen any school. I never seen anywhere they are teaching this adding of how many digits. It's about a 12-digit number. They never, because they know very clearly if they teach the 4-digit, you will be able to perform all the other digit additions, even up to 100 digit. I remember my son, when he was in 2nd standard, he take a big paper. He asked me to take a printout. All the papers, numbers. Okay. Then this is about 10 digit. Here 10 digit. He put all over the wall 100 digit. Then he did a addition. and he showed it to my wife, his mom. Mom, I added 100-digit addition. Am I right? But nobody taught him. The teacher taught him only 4-digit, and he could do the 100-digit. Now the same thing here. When in a binary also, when we add number, we assume the 1 bit is carry bit is 0. We need 3 bit, and when I add the number, I will get a sum and a carry. If it is 1 or 0, then the sum is 0, carry is 0. Sum is 0, carry is 0. If we have a number 1, then carry is 0, sum is 1. If we have a 1 plus 1, 2, then carry is 1, sum is 0. If I get 1 plus 1 plus 1, 3, I get carry is 1, sum is 1. So these are the 4 combinations we have. So when I add 2 numbers, when I add the 3 numbers here, A, B, carry in, sum, carry out. Okay, these are the possibilities. When you have this possibility, then let us put a table. Let us put the table here. The table, you draw them. A, B, C in, C out, and sum. Now I have a possibility that all the inputs are 0, then 0, 0. 0, 0, 1. Then I have a carry out is 0, sum is 1. 0, 1, 0. 0, 1. 1, 0, 1, 1. 1 plus 1 is 2. We have to add all the thing. Input we are adding A plus B plus C. When you add 0 plus 1 plus 1, 2, then become carry is 1, 0. Then I had a 1, 0, 0. Then I had 0, 1. Because 1 plus 0 plus 1 is 1. 1, 0, 1. 1, 0. 1, 1, 0 is 1, 0. Now I add 1 plus 1 plus 1, I get 3. All 3 are 1. Then when I get all 3 are 1, 1, 1, 1, 1, I get here 1, 1. That is 1, 2 is the thing. So this we have seen in the last session itself, but I'm just reminding you this. Now what we have done is very clear. I have a block which is a single bit addition. I have A, B, and C in. And I have sum and C out. Okay, this is the way we did the addition. Am I right? Okay, now let us see this. If we add one more bit, the C out goes as a C in, all wires, and this is sum, this is A, this is B. Then I have one more bit. This goes here, and A, B. And I have one more bit. And this goes here, A, B, and here sum, carry, sum. This is called S0, S1, S2. I've already told you that in binary, we always start from 0, not from 1. This is A0, A1, A2, A3. And this is B0, B1, B2, B3. And this carry out going this way. Then this is carry, see. Now let us see, I'm adding 2 numbers, 1, 0, 1, 0. Then I'm adding 1, 1, 1, 1. Let us assume that I'm adding these numbers. This is number A, this is number B. This is 0, this is 3. So A0 is 0. A1 is 1. A2 is 0. A3 is 1. B0 is 1. B1 is 1. B2 is 1. B3 is 1. Then this carry, always we assume that first carry is 0. Then when added 1 plus 1, 1 plus 0, the result is 1 plus 0 is 1. Then this get 1 and carry gets 0. And this goes here, gets 0. 1 plus 1 is 2. 1 plus 1 plus 0 is 2. So when I get 2, sum is 0 and carry is 1. Then this 1 goes here. 1 plus 0 plus 1, it is 2. So sum is 0, carry becomes 1. The 1 goes here. 1 plus 1 is 3. So sum is 1, carry is 1. So the result is this. When I add these numbers, I get now 1, 1, 0, 0, 1. Now let us add here. 0 plus 1 is 1. 1 plus 1 is 2, the 0. Then go carry 1 here. 1 plus 1 is 0, which goes here. 1 plus 1 plus 1 is 1, 1. So this is the way we add it. And this is the way we got it from the block. So this block, we can just draw like this. We can draw the block like this. We can draw the block. So A, B are input. A, B are input. A, B are input. And A, B are input. And S0, S1, S2, S3 are output. And C is output. All the other connections are internally. So I can erase this coolly. I can erase this. Now I draw it once again. I draw it once again. Now we'll understand it. I draw it. Okay. After drawn it, I have 4 outputs. 1, 1, 2, 3, 4 output. This is sum 0, sum 1, sum 2, sum 3, and there's a carry. And here is a 4 inputs. A0, A1, A2, A3. There are 4 inputs. B0, B1, B2, B3. I already mentioned to you. I have already mentioned to you that if we put a wire and put /4 and B, then it is called 4 wires. B0, B1, B2, B3. This is called LSB. This is called MSB, most significant bit. So for example, let us take this. If we put here /line A and the value is 0, 1, 1, 0. Sorry, let's make it easy. 0, 1, 1, 1. If you write like this, you know what is the meaning of this line? That you have to be very clear. This is the meaning is I have 4 wires. I have 4 wires. Each wire name is A0, A1, A2, A3, and this is MSB. So 0 goes here and 1 goes here, 1, 1. This is the meaning of this whole thing. Instead of writing 4 lines, A0 to A3, and this number I write it. Even we shorten this. We don't write this actually this much big. We write as a 7 in the hexadecimal form. It is easy. I told you in hexadecimal, so this is a 4. Hexadecimal 7 means 0, 1, 1, 1. That's why I told you that even though 7 is only 3, since it's 4-bit, I make it as a 0. You need to show the 0 in binary. You cannot write only 3 digit. That has to be, you have to draw the 4th bit also. So I write this picture differently. See here, I draw the picture totally different. See here, A, 4, B, 4, sum 4, carry. That's all. We do that. So you give 2 numbers, you get this as a result. I can add this 4 to 8 also. I can add the 4 to 8. Okay, then you will get this 8 and carry is only 1. We write like this. For example, you know how do I write here? 78 plus 45. Okay, the 78 is not 78 binary, it's a decimal. It is 78 hexadecimal. 7 means 0 1 1 1 1 0 0 0 7 8. 45, 4 is 0 1 0 0, 5 is 0 1 0 1. That's why I told you the previous videos are very important. You need to practice them and come here. Now you add them. 1 plus 0 is 1, 0 plus 0 is 0, 1 1 1 1 2 0 1 1. That's what you get. Carry is 0. So the carry is 0. Sum is 1011. That is B. This is B. See that both are B. So 45, 78 plus 45 is equal to BB. Sorry, this is D. 110 is 14. 13. 13 is D. Sorry, it's a mistake. 1011 is 11. So both are slightly confused. So 1011 is 11. 8 plus 4, 8 plus 2 is 10 plus 1, 11. This is 8 plus 4 is 12 plus 1, 13. 13 is BD. So 8 plus 5 is 13D. 7 plus 4 is 11B. If you do that addition also. So please understand this. We will be using predominantly 8, but you can have anything, 16, 32. As I mentioned to you that if I have a 8, if you put 8 here, the mean is I have 8 single digit adders are there. It is 8. It's 8 are there internally. 8 are there. If you put 8 here, it means there are 8 blocks. Each one will do 1 bit and the carry will go to next bit. So this is called 8-bit adder. Am I right? The same way, when you add a 8 bits, you will get the 8-bit answer, sum plus 1 carry. You get actually 9 bits. Same way, if you do 8-bit subtractor, 8, you get a 8-bit difference, and then there is a borrow 1 bit. That means that when I am subtracting 75 by 45, 5 minus 5 is 0, 7 minus 4 is 3. I get 30. And no borrow, 0. Suppose by chance I subtract from 45. You know one thing, what is the subtraction now? This is hexadecimal. Okay. So when you normally decimal you do means 10 means you will borrow 1. Then it becomes 10. 10 minus 5 is 5. Then this becomes 3. 3 minus 4, no. You borrow 1. 13. 13 minus 4 is 9. And there is one value borrow. Am I right? Or that's why you call this as a minus 95. You do that. Okay. Sorry, minus 85. How? So it's 4. How come I? Okay. 35. Sorry, we have a 40 actually. Originally, that's a mistake. Sorry. Originally 40. 40 minus 45 we subtract, we get 95. Because we borrowed, it became 33. Otherwise, originally it was 40. So you get 95. So I got confused a minute, fine. So what I'm trying to tell you is that you put minus here, but there we call this a borrow. So this is the way all the blocks are working. So I have a block called adder in binary. I have a block called subtractor. Now let us do the same thing for multiplication. So when I multiply the number, you say 110 multiply by 1 1 1 0 is, you get 110. Then this numbers when multiply, you say 1 1 sorry 110. You add them 0 1 0, then 1 goes here, 1110. You get this answer. How much is this? This is 16. This is 2. How much? 18. This is 6. This is 3. 63 is 18. Am I right? So this is the way we do decimal multiplication. We do binary multiplication. So no, what I'm trying to explain is learn how to build by block. That has to be understood in the binary. Okay. So in the binary, we have about 4 operations. The first operation is addition. The second operation is subtraction. The third operation is multiplication. The fourth operation is division. But in multiplication, if I give 8-bit number, I'll get 2 8-bit number outputs. Because for example, if I say 90 multiplied by 90, okay, I get 0 0 81. You get 4 digits in decimal. Same way in binary, when I multiply 8-bit into 8-bit, I get 16-bit. So I need to have this 8, that one number. We call low, high. We call low bit, high 8-bit. That's why we call this HL. We call high and low. Same way, when I have a number, I divide. Then also the thing is like this. Okay, I'll give an input as thing, then I'll get quotient and remainder. So if I divide the number 30 divided by 5, sorry, we put 6, 7, then 4 7s are 28, I get 2, I get 4 here, I get 2 here. So 2 is the quotient, remainder, 4 is the quotient in division. So let's not go in deep of that, but we try to understand how this logic is working. If you would like to go in depth later, we can discuss. But right now, I'm trying to give it a top level. So these are the 4 operations we handle: binary operation, subtraction, multiplication, division. Okay. So later videos, I'll explain thoroughly how to do multiplication. Right now, don't worry. We'll take it as a block. The same way, we have other 3 operations. We know that in binary, we have operation called AND. We have operation called OR. We have operation called NOT. Same thing here. What is inside is, people have a block. I have a block. Now let us take very clear, what is this AND operation? What is this OR operation? What is a NOT operation? It's quite simple. These are AND operation is AND. The meaning itself says. That means that my input, let's say I have a 2 bits. Then if both of them are 1, the output is 1. Both are 1. That's why A and B. Same way in the OR operation, if A or B is okay, output is 1. If anyone is 1 is fine. 0 1 is fine, or 1 1 is fine. But in the AND operation, both must be 1. Same way, NOT operation, NOT of input. 1 means 0, 0 means 1. These are the, apart from addition, subtraction, multiplication, division, we have another 3 operations. If you know this 7 operation thoroughly, then you can do wonders in both programming and digital electronics. These two are totally driven by this 7 operation. All your programming, whether you may call it as a C or Python or Java, all are built over these operations. Nothing more than that. Okay. Okay. Now we get into the same thing like integration. Okay. The integration is this. I have, let us say, 4 AND gates. In AND gates, there's no carry and out. It's a 2 input, there's output. It's a 2 input, all are individual. All are individual. This, I call it as a A0, A1, A2, A3. And we call this as a B0, B1, B2, B3. Then let us make the output as a Y0, Y1, Y2, Y3. Here there is no carry and dot, it's all individual. Okay, now if we have a number 1, 0, 1, 0, excuse me, sorry. Oh, sorry. Then I have a 1, 1, 1, 0. That's fine. Now, when I do the AND operation, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1. So the result is, if I write 1, 0, 1, 0, 1, 0, 1, 0, then 1, 1, 1, 0, then the result is becoming 1, 0, 1, 0. If you write them like this, easy way, this is A, this is E, and this is A. See that? There's no relation. You cannot say like this. If you put here C, if you put C here, the answer is 8. Because 1, 0, 0, 0, 1, 0, you cannot say that how the operation will result to this. There's no relation. It's only because AND operation. So how do we write this is, once again, we draw them like this. It's as simple. That is, we put a table, once again a block. I put here 4, 4, A and B and Y. That's it, /4. If we say /4 mean internally 4 AND gates are there. Individually. If you put 8, it means that the 8 AND gates are there. It's a block. We don't draw 8 wires, 8, 16 wires, here 8 wires. No, we don't do that. We just draw it like this. That's the way the whole industry follows the standard. Okay, same way, I'll be doing the OR function like this. But when you do the AND, when you do the NOT, I have only 8 inputs. That is A, 8, and B8, Y8. And this is the AND operation. So understand, these are all 8 bits. For example, if you want to add 2 numbers in decimal, It's like this. Somebody will give two numbers. 25, 36. It's a 8 YS. And 25 means 0010. 5 means 0101. 3E means 0011. E means 1110. Then, if you're not clear about this decimal, hexadecimal, go back to my previous videos and master it and come here. Then this is going inside your AND gate, adder. Then the adder will perform, because he has a 8 adds are the things are there. He will perform 10, 10, 01, 01. See, what he is getting is 25. Actually, he is not getting. He is getting only this number. When I write 8 means 8 YS. Each Y, see, when I say 8 means 8 YS. He gets these numbers. He actually gets, this is MSB, this is LSB. 0, 0, 1, 0, 0, 1, 0, 1. This is a reality. See, this is real. This is for you to understand. But normally what we think, I am giving 25, the 25 is going. Actually, 25 is not going. 1010 is going. For you to understand, simply we are writing this number. This guy receives only binary. So in decimal, there is nothing called hexadecimal addition. It's only a binary addition is there. Same way this 36. 0, 0, 1, 1, E, 1, 1, 1, 0. He performed the addition. 1 plus 0 is 1. 1 plus 1 is 1. 1 plus 1 is 0, 0, 0. 1 plus 1 plus 1 is 3. 1, 1, 1. Carry is 0. Then he add E and 3. He gives output as E3. So 2, 5 plus. Oh, this is not 2, 5. I've given writing 2, 5. I put A5. Fact, mistake. I put 1, 0. So A5. So A5 plus 3. You add, you will get E3. E is 5 is how much? 5. E is 14. Okay. Add them. 14 plus 10 is 19. 19 minus 16 is 3. And 1 goes here. So 10 plus 1, 11. 11 plus 3 is 14. 14 is E. So we get this E3. This, if you understand, is very good. I've explained to you that how the whole thing is happening. Okay. It is up to you to get this thing. So I have given that how in a decimal, in a binary system or digital electronics. I'm worried about digital electronics, not the number system. I'm not teaching here mathematics. I'm teaching about number system for your digital electronics. So here we have so many blocks. One block is called adder block. This other block called subtractor block. This other block called multiplication block. This other block called division block. This other block called AND block. This other block called OR block. This other block called NOT block. Each block, what is the input? 8 plus 8. Then this guy is having output sum as 8 and carry is 1. If you don't write anything, it's 1. Same as subtractor. 8, 8, A, B. I get difference, I get borrow. Multiplication. I have number A, number B. And then the output is low and high. Low 8-bit, high 8-bit. Division. I get 8, 8. I get here what? Quotient and remainder. Then AND gate. A, B, Y. 8-bit. 8 YS. Think of it. 8, 8. 8. A, 8-bit. Y, 8-bit. So this is what the whole system works. Okay, so don't if you understand this, actually this why I explained this 7. There's a reason. These functions, these 4 functions are generally called arithmetic functions. These 3 functions are called logic function. Arithmetic. So together is called ALU, arithmetic logic unit. This is what I have drawn here. Is there exactly in your microprocessor? You know that 8-bit microprocessor, 16-bit, 32-bit, and all. We'll discuss in digital electronics all these things. But initially, let's forget about this one. We'll take about only 8-bit. In 8-bit microprocessor, that's a very famous all of the time. That 8-bit microprocessor is having all these things. But if you understand this 8-bit microprocessor, digital electronics and number system, you'll be able to understand the entire microprocessor, 16-bit or 32-bit, all are easy. So I have started from very simple, but I have finally finished, which is a part of your microprocessor. Okay, please go through it and try to understand it. That's a very, very important. Okay. Then when you see the videos few times, you'll be able to understand. First time, every time you see it, have a concentration. Then once you have understood it, then practice. Which I give problem during the class. Okay, during the class I give the problem. So those problems you solve it. Okay, then you will be able to have a good idea. The thing is that these things bit by bit, everything you understand. So then, for example, in a sequential logic, I'm going to explain about memory. In a combinational logic, I'm going to explain about what is combinational logic, everything. And tri-state logic, how a switch operates. When all of them together separately and combined together, you get a microprocessor. Nothing more than that. There's nothing inside the microprocessor. But that does wonders. Okay, that is a very critical part for in your electronics, in digital electronics. So with this, let us fairly close this number system. Okay, so if you want to hear more, I'll have one more recording of number system, 5th unit. Right now we will have about 4 sessions. Okay, thank you. Bye bye.